Welcome, polar bears and polar cubs. It's combustion time. So, where, why, and how does combustion kind of happen? Well, it takes oxygen combined with some kind of substance. It releases a large amount of energy in the form of heat or light. We're burning molecular organic compounds, meaning they're going to be a bunch of C's and H's, maybe some O's. We're always going to add oxygen. Because if you have a fire and you take away the oxygen, the fire dies due to the fact that it can't breathe. Add the heat symbol, so we're always going to have the delta triangle or the heat symbol over top of our arrows, and our products always produces or fills the other side with CO2 and water. So a hydrocarbon, the example of this would be like CXHY. It's going to have carbons and hydrogens, and then it'll produce carbon dioxide and water. An organic molecule can have oxygen, so therefore it's CXHYOZ. So we're going to run through one example of each with you, and we'll see how you do. So prime example, methane. This is what comes out of your kind of gas pipes at home. It's a gas plus oxygen gas with heat is going to produce CO2 gas plus, now this is water, however, it's being heated, so it's gas, water vapor. We're going to go ahead and balance those. So when we balance this, I'm going to start with methane, and I'm going to say, hey, that has 4 H's, so I need a 2 here, 1 C, 1 C. I seem to be balanced. Then it becomes 2x equals 2 plus 2, so x must be equal to 2. That's a foolproof way of determining your coefficient on the oxygen. Let's try the next one. This is C5H10O5 plus O2. These are gases. Well, actually, this would be a solid. The reason it's a solid is most organic molecules with that many oxygens would be solids. On a worksheet, I would make sure that I let you know. And then you have, again, water vapor because we are being heated. This one, again, I'm going to start with C5H10O5. I see that has 10 hydrogens. That puts a 5 here. 5 carbons. That puts a 5 here. Now, the hardest part when it comes to balancing combustion reactions that occur with an oxygen-rich organic molecule is now when you're balancing out the oxygens, like up top, you have 5 plus 2x is going to be equal to however many oxygens you have on the product side. Well, 5 times 2 gives you 10, plus 5 times 1 gives you 5. So what ends up happening is you're going to have 2x is equal to 10. X then is going to be equal to 5. So we'll end up putting a 5 here in order to balance it. And that's combustion as a type of reaction. Now, I will tell you a lot of times what I have found to be easiest is multiplying this by 2 going through, and if you had to, then dividing your coefficients by 2 to get the lowest coefficients possible. All right, best of luck on your worksheet. There's a video there telling you how to type everything in, and let me know if you have any questions.